Here's my experiment running. I've got the little 633 chip here, crystal oscillator, and then the rest of that is just split supply stuff going on there that I always have on my board. Anyways, we're looking at the output right now. This right here is the 1 megahertz signal that I was looking at, but if we zoom in here, you'll see that, you really can't at where I'm supposed to be getting, let's see, 1.05. I guess you kind of see it, but let's see, turn this frequency up to 1 kilohertz. Oh, 2 kilohertz. All right, so right here you actually start to see some distinct peaks in frequency. So you'll see that that's about 1 megahertz plus 2 kilohertz right there. So that might be my baseband. But when I shorten the frequency, you'll see when I go from 2 kilohertz to 1 kilohertz, it kind of mashes together. And my assumption is that this is a limitation of the actual picoscope itself. So what I did for my experiment is I just went with a lot higher frequency, basically the max of 1 kilohertz. And so now we have our 1 megahertz carrier frequency, and then down here you see it's about 900 kilohertz, which is our low side baseband, and then right here we've got 1.1 megahertz, which is our high side, and lots of little harmonics in this whole entire thing. If we go down here, turn this back down to 500. 500 was my original thing, but that turned out to be a little problematic, so let's turn the frequency down. We're at about 12 kilohertz here. So right there's our baseband frequency, and yeah, that's pretty much it. I did put an antenna on this just to see. It's really noisy, but I was able to get it to where you can actually hear 500 hertz, 600 hertz audio frequencies playing over on the radio I have on the other side of the room. But that's about it. Let me know if you have any questions.